Welcome to our virtual learning. This is the third video of confidence intervals for the mean for the case sigma known. In the previous video, we got to an example of finding the margin of error. So we're going to do this example now. Remember example 1, it was a random sample of 40 student athletes. 40 is a number large enough to guarantee that the distribution of the sample means is approximately normal or could be approximated by a normal distribution. And what that means is that we can use the formulas that we defined in the previous video to calculate the margin of error. We're going to use data in example 1 and a 95% confidence level to find the margin of error for the mean number of hours spent on required athletic activities by all student athletes in the conference. Now, we're going to assume that the population standard deviation is 2.3 hours. This is a requirement. We need to know what is the standard deviation because we are assuming that in this case we know what is the standard deviation of the population. Sigma is known, equal to 2.3. The sample is random, and n is equal 40, which is greater than or equal 30. So we can use the formula for the margin of error that we explained in the previous video. The z-score that corresponds to 95% level of confidence is 1.96. This implies that 95% of the area under the standard normal curve falls within 1.96 standard deviations of the mean. 1.96 to the right and 1.96 to the left. Remember, how do we find this value? We know that the area in blue is 95%, and therefore the area on the tails is 5%, half on the upper tail and the other half on the lower tail. Half of 5% is 2.5%, and therefore to find this value we go to the standard normal table and we find the value so that the area to the left is 97.5%. And if we go to the table and we find that value, it will be 1.96. And to find this other value, we find the value so that the area to the left is 2.5%. So we put together this z-score here. Okay, so once we have the critical value, we know the standard deviation and we know the sample size, we can use the formula for the margin of error. Z sub c is 1.96, 6 minus 2.3, n is equal 40, so the margin of error is going to be equal to 1.96 times 2.3 divided by the square root of 40, approximately 0.7, about 42 minutes. So you are 95% confident that the margin of error for the population mean is about 0.7 hours, again assuming that this process is conducted a large number of times. Okay, now a review of the process. When we want to find a confidence interval for a population mean with sigma known, we need to do the following. First, we need to verify that sigma is known and we need to verify that value. We need to verify that the sample is random, and we need to either see that the population is normally distributed or the sample size is large enough so that we can guarantee by the central limit theorem that the distribution of the sample means is approximated by a normal distribution. Once we verify this, then we know that we can use the sample statistic x bar as a point estimate of the population mean. How do we calculate the sample mean? Well, we just add the values in the sample and we divide by the sample size. Okay, so once we have the point estimate, we would like to construct the interval. So we need to find the critical values, and to find the critical values, first we need to set the confidence level. We find the critical values. And how do we find the critical values? We use the standard normal table. Okay, but the level of confidence has to be given. the researcher sets the level of confidence. Once we have the critical values, then we can calculate the margin of error by multiplying the critical values times the standard error of the mean. Then, to find the left endpoint, we subtract the margin of error out of the point estimate. And to find the right endpoint, we add the margin of error to the point estimate. We know that the population mean is going to be in between these two values with C level of confidence, assuming that this process is conducted a large number of times. Okay, so example of constructing a confidence level. Again, we're going to use data in example 1 to construct a 95% confidence interval for the mean number of hours spent on required athletic activities by the student athletes in the conference. Recall that the point estimate in that case was 21 hours and 6 minutes, or 21.1 hours, and the margin of error was 0.7 hours or 42 minutes. Okay, to find the left endpoint or the lower endpoint, we take the point estimate and subtract the margin of error. So 21.1 minus 0.7, 20.40. Okay, and then the right endpoint is going to be the point estimate, 21.1 plus 0.7 or 21.8. And then, right, we can say that with 95% level of confidence, the mean of the population is between these two values. Okay, we can graph the interval. The interval is centered at the point estimate, and the lower end of the interval is calculated by subtracting from the point estimate the margin of error, and the upper end is by adding the margin of error. So every time we produce a confidence interval, we say with certain level of confidence, in this case 95, we can say that the population mean number of hours spent on required athletic activities is between 20.4 and 21.8 hours. Okay, we're going to do another example. Again, I'm going to read through the statement and I'm going to extract all the important information. A college admission director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, so random here is good, 20, red lights, because 20 is not greater than or equal 30. Let's keep reading. In a random sample of 20 students, the mean age is found to be 22.9, so this is going to be our point estimate, right? 22.9 years. Now, from past studies, the standard deviation is known to be 1.5 years. So everything here is okay, except that we still have 20 students, right? Now, and the population is normally distributed. This is good news, because the fact that the population is normally distributed, it will guarantee that the distribution of the sample means is going to be approximated by a normal distribution for any sample size. In this case, 20 is a good sample size. Now, we want to construct a 90% confidence interval of the population mean age. So what is the process to produce this 90% confidence interval? Well, first we need to find the critical values. Once we have the critical values, we build the margin of error by multiplying the critical values times standard error of the mean. And the standard error of the mean is the standard deviation of the population divided by the square root of the sample size. This is it. n is equal 20, x is equal to 22.9, sigma is equal 1.5, and the critical values that we calculated in the first example is 1.645. The margin of error at the 90% confidence level can be calculated by multiplying these numbers here, and this turns out to be 0.6. So then the left endpoint, or the lower endpoint of the interval, is going to be the point estimate minus the margin of error, and the right or upper endpoint is going to be point estimate plus margin of error, and we get this interval that we can graph as we did before. Okay, now we can say that with 90% confidence, right, that the mean age of all the students is between 22.3 and 23.5 years. Okay, so now how do we interpret the results? First, keep in mind that the population mean is a fixed number. Okay, it's not gonna change, and given that fact, and given that we are producing intervals, right, with a given margin of error, then it may happen that that number, the population mean, is either in the confidence interval or not. We always say with 90% confidence. Okay, so what we mean by that? We mean if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain mu, or this picture here. So notice that this is, this is one interval, one confidence interval that it was produced by using a margin of error, okay, and a point estimate. But if we change the sample, then we will have a different interval centered in a different point estimate. So the length of these two intervals is the same, but they are centered at two different points. This is another interval centered at this point with margin of error to the left, margin of error to the right, and this is the same. Okay, so now if we assume that the population mean is this value here, right, and we calculate 10 intervals, then 90% confidence means that in 9 out of these 10 intervals will contain the population mean. Okay, so that's the idea of 90% confidence. Okay, an incorrect way to say this will be there is a 90% probability that the actual mean is in the interval, and then we say the interval. Okay, but rather, if we produce several intervals with different point estimates and the same margin of error, then 90% of those intervals will contain the population mean. Okay, with this we finish the third video for section 6.1.